Okay, so the best way to understand bearings is to go back to the basic ones first. Once you understand the basics, then these complicated ones or more advanced ones will be much easier to interpret. So find the bearing of A from B and then the bearing of B from A. So I drew something here. These alternating angles or alternating interior angles or Z angles. I'm not very sure which word you are using. So for me, I think I'll stick to Z angles, but it's basically the same thing. So find the bearing of A from B. So to find the bearing of A from B, what you do is you go to B. Remember, A from B. That means you're starting from B going to A. So you can just go to B. B is here. And then you draw a north line on B. This north line should look like this. But of course, we already have one here. So all you need to do is draw an arc from B going to A, this line A. So you can just draw an arc like this. Of course, this arc should be in the clockwise direction, like this. So the bearing of A from B will therefore be 130 degrees. And you're done. And then for part B, the bearing of B from A. So in this case, you're not starting from B, you're starting from A going to B. So what you do is you go to A. This is your A. Draw a north line. Usually this is a broken line. It should be parallel to this. So you have a north line like this. And then now after you do this, you draw an arc in the clockwise direction from A going all the way to B, like this. So now your job is to find this angle here. Of course, as you can see, we have a Z angle here. I decided to draw it here so that you can easily see it. So we have a Z angle. Whenever you have a Z angle, this angle is the same as this. I mean, whenever you have Z angles, this will always be the same as this. So if this is 130, then this is also 130. So that means this angle here, just this part alone, will be 130 degrees. And then the other part is 180 degrees. So for you to find the bearing of B from A, which is this thing here, you can simply add 130 to 180. So when I add this to this, I'll get a 0, a 1, and a 3. So my bearing of B from A will therefore be 306 and 10 degrees, and you're done. And then the next one is similar to that. So find the bearing of Y from X. So Y from X. In other words, you're starting from X going to Y. So what you do is just go to the starting point and then draw a north line. Fortunately, the north line is here. So all you need to do is draw an arc in the clockwise direction like this, going all the way to Y, because it's the bearing of Y from X. So now, to find the bearing or this angle, you know that a full revolution has 360 degrees, and then a portion of it, this side here, is 150 degrees. So to find the bearing of X from Y, I mean Y from X, you can simply say 360 degrees, this entire thing, minus this part here. The moment you remove this part, you remain with this, minus 150, so you have 210 degrees. So this will be 210 degrees, and you're done for part 1. So this is 210, and then find the bearing of X from Y. So on part B, as you may have guessed, you start from Y going to X. Remember, it's from Y to X. So the bearing of X from Y, you go to Y, you draw a north line, since the north line is not, has not been drawn for you here, and then you draw an arc in the clockwise direction from y all the way to x, like this. Yeah, so now your job is to find this angle. Of course, you can extend this like this, or as you can see here, we have two angles which are supplementary. So when I add this to this, I should get 180 degrees. So you can say x plus 150 is equal to 180 degrees, and then I can solve for x. Of course, there are so many things you can do here to solve for x, or to find this angle, which is 30 degrees. So this angle is 30 degrees, but I'm not going to write 30 degrees because I'm dealing with bearings. Remember, bearings should have three figures. So this is 0, 30 degrees. Another one can use z angles here. You can find this angle, which is like, of course this is a straight line, and then this one is 150, so you can say 180 minus 150, you'll find 30 there, and then you can take advantage of the z angles, or you can do whatever is easier for you. So now let's look at more advanced problems like this. So in the diagram below, the bearing of C from A is 160 degrees. Angle ACD, I meant B, I think. Yeah, this was supposed to be B. Angle ACB is 30 degrees. And then AB is equal to AC. And then find angle BAC. Find angle BAC. So now we have this information here. The moment they tell you that AB is the same as AC, that means the two sides being formed by these two arms, the two angles being formed by these two arms with the third arm will be the same. So this and this are forming this and this with this arm. So that means if this is 30, this one will equally be 30. So now to find this angle, you know that the sum of angles, the sum of interior angles in a triangle is always 180 degrees. So you can say 30 plus 30 plus, let's just call this one x, is 180 degrees. And then this plus this will be 60 plus x is 180 degrees. And then you can just collect the like terms so that you have 180 minus 60, which is this minus this is 120. So angle BAC is 120 degrees, and you are done. And then find the bearing of A from C. So remember, the procedure is still the same regardless of the shape you've been given. So the bearing of A from C, just go to C. Here is your C. Draw a north line parallel to this, like this. You can call it north. And then now you can draw an arc from C going to A. So this is my A, this is my B. Maybe I should add part C, where you find the bearing of, let's say, A from B. Yeah, let's do this. So for me to find this, I'll draw an arc from here going in the clockwise direction all the way to A. So this is where my A is. That's my A there, this line here, where A is, and then you have that line. So for me to find this, all I need to do is, of course, I know that this is 360 degrees, and then as you can see, we have a Z angle here. So if this is 160 degrees, then this is also 160 degrees. Yeah, so that means you have 160 degrees this side, and then you have 180 degrees this side. So altogether you have 180 plus 160, then this plus this you have a 0, this plus this you have a 14, this plus this you have a 3. So that means the bearing of A from C is 340 degrees, and you're done. And then lastly, on part C, we have the bearing of A from B. So the bearing of A from B, that means you're starting from B going to A. Okay, I was actually I wanted the bearing of A from C. Okay, yeah. So in this case, we are starting from B going to A. Although my plan was to find the bearing of C from B. But anyway, let's solve it since we have brought it in. So to find the bearing of A from B, just go to B, this is your B, and then you can draw a vertical line like this, parallel to the north. You can call it another north. And then to find the bearing of B from A, just draw an arc from this line here all the way to that point there. Yeah. So now to find this angle, you know that this one here, what did we find? And this one, okay, we found 120. So all you need to do for you to find this bearing is to find this, and of course you know that this one plus this is 180 degrees. These two are supplementary angles. Some people call them U angles, or what do you call them, ally? I don't know if it's ally. I haven't taught mathematics in a while. I've been teaching another kind of mathematics. So to find this, of course, you know that this plus this is equal to 360 degrees. So I can just add these two and subtract from 360 degrees. So this one plus this, that will be 280 degrees. And then if I can subtract this from 360 degrees, have this minus this, we have an 8, so that means this is 80 degrees. So now for me to find this, I can just take advantage of the fact that these two lines are parallel to each other, and these two are therefore supplementary angles. So when I add this to this, I'll get 180 degrees. So I can say 80 plus, we can call this one x, or maybe let's use y. Too much of x is not good, so you can say y is equal to 180 minus 80, and then y will therefore be 100 degrees. So I know this one appeared like a 90 degrees angle, but as you can see, it's not. So as long as they have not told you that it is, and they have not given you any small square like this, you have no right to assume that it is right angled. So in the diagram below, A, B, and C are points on level ground. The bearing of B from A is 032 degrees. And then angle ACB is 100 degrees, and then angle AC is equal to BC. So this, the distance AC is equal to BC. Find the bearing of A from C. So to find the bearing of A from C, I'm sure by now you can tell what the first step will be. You draw a line, a north line on C, because you're starting from C going all the way to A. And then you can draw an arc from C to A like this. And then now your job, or maybe your next task, is to find this angle. So now how do you find this angle? Of course, you've been taught that these two are the same. So like I said in the previous example, if these two are the same, then these two angles will be the same. Yeah, so now let's find these two angles. Let's just call them x's. Okay, x is back, so you can say x plus 100 is equal to, remember this is a triangle, the sum is always 180 degrees. So you can add these two x's and then take this one to the other side, or subtract 100 from both sides depending on what you were taught. And then this minus this will be an 80. You divide both sides by 2 and your x is 40. So that means this is 40 degrees and so is this. So altogether here we have a 72 degrees. So my plan here was to take advantage of the z angles here. As you can see, we have a z here because this is parallel to this. So if this is a z, then whatever this is, it's exactly the same as this. So to find this one here, I can just add this to this. So that's 72 when you add 32 to 40. So this angle here is 72, and of course we know that this is a straight line, so this one is 180 degrees. So to find the angle from here to there, or the bearing of A from C, you can simply add these two. So we have 72 plus 180, this plus this, that's a 2, and that's a 5, and then we have a 2. So that means the bearing of A from C is 252 degrees, and you're done. And then on part B, find the bearing of C from B. So now in this case, we are starting from B, going to C. So I'll draw a north line again like this, and then after drawing a north line like this, I'll draw an arc from here going all the way to this line here. This is where my C is. Remember, from B to C. So this is my B, from B all the way to C. So now for me to find this angle, of course we have this thing here. These two are complementary angles, or you can use the fact that this is a z angle. Actually, this is much better. We have a z angle here. It looks something like this. So whatever this is exactly the same as this. And on this part here, we have a 72 degrees here and 100 degrees there. So to find this angle here, I can just add these two. So I can say 100 plus 72. So this will be 2, this will be 7, this will be 1. So that means my angle here is 172 degrees, which is my answer to part B. So the bearing of C from B is 172 degrees. So watch out for part 2. I think I'll make another video with a few more problems which are a bit different from these, but of course the concept will still be the same.